Hello everyone. Today we will be expanding on our idea of solving systems of equations. So to recap what we've learned up to this point, when we're doing systems of equations, and the key word there being equations, is that we have two linear equations in which we work to solve to find that one point that they have in common. Of course, there are always exceptions, such as parallel lines, which never touch, and then also coinciding lines, which run one on top of the other. But now what we're going to be looking at today is inequalities versus equations. Now, if you recall from Unit 2, whenever we have inequalities and we go to graph an inequality, keyword here, we're looking at graphing systems of inequalities. Anytime we went to graph an inequality, what we did was draw in the line, decide whether it is solid or dashed based on if it was an equal to or not equal to type problem, and then finally we would decide whether we were shading above or below based on the idea of whether it was greater than or less than. When it comes to systems of inequalities, the idea is the same, except the only exception here is now we're doing it twice. So, the steps to graphing a systems of inequalities, and I will say with systems of inequalities, graphing is the only way to find the solutions because there are just so many solutions, you can't really put it into a numerical sense. So graphing is kind of the only way to solve systems of inequalities. So step number one of solving a systems of inequalities is to graph and shade the first inequality. That includes deciding whether it's a solid line or a dashed line, and then shading above or below. Step number two is exactly the same, except this time what you'll be graphing and shading is the second inequality. And the very last step to this process is figuring out where the two inequalities and their shading overlap. So we find the overlap. And take note that when you find that overlap, that right there is your answer. So the overlap section, whenever we shade, is going to be our answer. For proper English there. So let's look at an example together. So example number one, you'll notice that there's quite a significant gap between the graph and the example. The reason for that being is we do need it to be in that format still, in theory, of y equals mx plus b. I understand that these are inequalities, so it's not going to be equal to, but we still want the y to be by itself. So if the y is not by itself, you're going to need to do a little bit of solving before you graph it. Now the first equation here, and I wanted to make sure you can use any colors. If you'll notice up top at the beginning of the notes, it says you'll need a lot of colors here. And I would highly recommend you do multiple different colors. Trying to do this with a single pencil and just kind of shading lightly doesn't always work out the best, but it is possible. And I'll show you kind of what I mean by that later. So when we're looking at the first equation here, I'm going to label this as my green equation. The one thing that we do know is that the y-intercept is going to be at -4, and our slope is a 3/1. So I'm going to go ahead and graph that, and I'm going to start at -4. I'm going to go up 3/1, up 3/1. And I'm going to kind of repeat this process all the way up. Same thing going the other direction. Again, these are linear, so we're looking to create a straight line. Now, before I draw my line, I do need to decide whether it's solid or dashed. This one's going to be dashed because it's not equal to. So I'm going to go ahead and draw a dramatic dashed line going all the way through this. And then I need to decide where am I going to shade. This is a greater than, so I should be thinking above. So look at your graph and say, where is above? Again, you may need to refresh your skills as far as shading goes. We did those in the last unit. When we first looked at these, we looked at picking a point on each side. 1 point over here and 1 point over here. If the point worked, that's the side you would shade. If the point didn't work, you would shade the other side. Okay? Now when we look at our second equation, and again, that's step number 2, graph your second equation, inequality. We do need to get the y by itself. So I'm going to go ahead and get the y by itself through a little bit of algebra. Less than or equal to, I'm going to put the x first. And then divide by a -2. Make sure everything's getting divided by a -2. That's y is, whoa, we divided by a negative. Be careful, that inequality sign needs to switch now anytime you divide or multiply by a negative. So we divide by a negative, that gives me 1/2 x minus a 3/2. Now it's time to graph that one. So my y-intercept is basically a -1.5. That's going to be right about here. And my slope is 1/2, so that's up 1/2, up 1/2. This one may feel a little uncomfortable to graph because you are landing in those half markers, because anytime you move that increment of 1, you're actually moving to another half marker, which can be a little uncomfortable for some. So just take your time with it. Don't rush it. And I think I can do one more on this side. This should be a solid line because we're looking at it being equal to, and greater than means I'm shading above. Okay. Now once you've shaded, well, one thing you should notice is in this section, we only have green. And in this section, we only have purple. Those are the two sections that we don't want our final answer to come from. Our final answer comes from the section that has both green and purple. So we look very carefully at our graphing and we say, this is the part that has the overlap, and therefore this is my answer. Okay, and you do need to make it very clear whenever you're doing your answer key as far as what your actual answer is. Some of you may even find it helpful to go back and kind of get rid of the stuff that is not part of your answer. So this is not part of my answer. There was no overlap there. And over here, this was not part of my answer, so there is no overlap there. We're only looking at the part that is the overlap. So that right there is my solution. If you choose to leave everything, that's fine, but I would recommend you clearly label, clearly highlight, darken. If you're doing it with a pencil, really make that section darker and label it as your answer. You need to be as clear as possible as to where your answer is, because you did a lot of graphing and a lot of coloring and there's a lot going on. But what I'm looking for here is, do you actually know where the answer is? And the answer should be in that overlap. And in the second example is very similar to the first. So we'll take notice that the first equation is not in a y equals format. So I'm going to go ahead and need to get that to a y equals, which is basically as simple as adding the x over. So we'll have a positive x and a positive 2. I'm going to go ahead and graph that problem now, keeping in mind there's my y-intercept, and my slope is basically a 1/1. So I'm going to start at positive 2 and do my 1/1 and get my graph in there. Boop. Keeping it going. This should be a dashed line because it's not equal to, so I can go ahead and draw in my dashed line. And again, this process should be no different than the last unit. We're looking at shading less than, so we should be shading below. Now the second problem we do need to be careful with, because this is an x is less than or equal to 3. Some of you struggled with this on your last test. So that means that I should be going to where x equals 3. That's where x equals 3. And we want to draw a line that is solid going through that. So it's going to run perpendicular to the x-axis, because every single point on this line is an x equals 3. This point right here has an x equals 3. This point right here has an x equals 3. Okay, so you want to draw a line where all the x equals 3, and now we want to shade less than. So thinking about where less than would be this direction. And just like the first one, we bring it home by saying, where's our overlap? Our overlap exists in this section right in the lower left-hand corner. And you make that very clear. I'm even going to write down here, this is my answer, just so that we can be very clear. Again, if you want to go back and eliminate any of this outside stuff, that is your choice, as long as you leave in the part that is included in the shading, which I will mention while I'm doing this to further explain this. You should be leaving in this solid line is part of the answer and this dashed line is part of the answer. So you can't take those solid and dashed lines out. They are part of the answer. Okay. Now what I would like you guys to do with the remainder of our time is I gave you 3 practice problems on the next page that are the exact same concept. In example 4, the y's are already by themselves. That's really nice. So that should just be a figure out the y-intercept and the slope and graph it. Same thing with number 5. They already have the y's by themselves. So find the y-intercept, the slope, and graph it. Making sure to do solid versus dashed, shading above or below, and then finding that overlap section as your final answer. Number 3 is the only one where you will have to solve both of those equations to get y by itself before even graphing. So I'd like you to try those problems on your own, and if you have any questions with them, you can go ahead and bring them to class on the next day that we will be talking about graphing systems of inequalities. So again, please complete those examples and graphing them down below, and then I will take questions the next time that I see you for a class, not for the quiz.